Myself, Dr. Shipra. I am here to take online classes of Plus One Chemistry. Today, I am going to teach the topic structure of atom, that is chapter number 2. So, this chapter includes the discovery of some fundamental particles. The fundamental particles are electrons, protons, and neutrons. In the previous chapter, that is basics of biochem, in the basics concept of chemistry, we have studied Dalton's atomic theory. So the Dalton atomic theory states that all the matter is made up of small particles. These particles are called as atoms. And the atom is indivisible in nature. It is indivisible in nature. But it still, this theory was discarded. The theory was discarded because at that time there was not the existence of electrons, protons, and neutrons. They were discovered later on in the later stages. So when the structure of atom was discovered, when it was discovered that all the matter is made up of small particles which are called as atoms, they are indivisible. The postulate failed later. This postulate failed later. So the reason is the discovery of electrons, protons, and neutrons. Second postulate of Dalton's atomic theory states that all the matter is made up of all the matter is made up of small particles. They are like elements. The atoms of the same elements are same, and the atoms of different elements are different. This postulate was also failed due to the discovery of isotopes and isotopes. So today we will be studying how the electrons were discovered. See, I am going to give you a picture of discharge tube. See, this discharge tube is containing an electrode that is called as cathode and one more electrode that is called as anode. The terminal which is attached to the negative end of the battery is termed as cathode. And the terminal which is attached to the positive end of the battery is called as anode. So what was done? Basically, one discharge tube was taken which is made up of borosilicate, which was made up of borosilicate. So the gas was added here like helium gas, neon gas, or some argon gas. That means one noble gas was added in the discharge tube. What happened? What happened to the cook? Why he took this? He wanted to find out whether there are some negatively charged particles or not. He just wanted to find out that. So What he did, he passed the current through cathode at the pressure of 1 atmosphere. When there was a pressure of 1 atmosphere, there was no conductance of electricity through the gas. Secondly, he increased the voltage and decreased the pressure. So, how did he decrease the pressure? He used for that vacuum pump, which was attached to the Crookes tube. So, with a vacuum pump, he decreased the pressure to the 10 raised to power minus 2 atmosphere. When the pressure was reduced, then there was green glow in the tube. There was green glow in the tube. Now he was about it. He was about it to decrease the pressure more. What will happen? He decreased the pressure to 10 raised to power minus 4 atmospheres, and he increased the voltage to 10 raised to power 4. The negatively charged electrode, the negatively charged electrode transmitted some rays. These rays were termed as cathode rays. So that's how the discovery of cathode rays was done. Basically, are TV tubes, picture tubes, that is, they are the cathode rays. Basically, these cathode rays were originating from the negative terminal of the battery when the pressure was reduced to 10 raised to power minus 4 atmospheres and the voltage was increased to 10 raised to power 4. Due to this reason, these negatively charged particles will be attracted towards the positively charged electrode. Behind the positively charged electrode, there was zinc sulfide coating, which began to glow when the stream of electrons was projecting on the spring. So, this zinc sulfide glow, began to glow. So, now we will study what are the different characteristics of cathode rays. The first character is these cathode rays travel in the straight line. Why these travel in a straight line? Because if any metal cross is placed in the path of cathode rays, they casted shadow. They casted shadow. So this means that these cathode rays they travel in the straight line. Second characteristic of these cathode rays, they are made up of material particles. How they are made up of material particles? Reason is, if we put some paddle or some wheel in the path of cathode rays, these cathode rays rotated the wheel. So this showed that the cathode rays are made up of material particles. So these cathode rays are made up of material particles, and these cathode rays, when we put some electric field into it, then there is one terminal that is positively charged terminal and there is one more terminal that is negatively charged. So were these rays were more directed toward the positively charged plate. What is the reason? Why these were directed more toward positively charged plate? Positively charged plate. Just a minute. Positively charged plate. The reason is these are made up of negatively charged particle. As these are made up of negatively charged particles, so they were more directed toward the positively charged. And the third and the fourth characteristic property of the cathode rays is when the magnetic field was applied to the cathode rays, the cathode rays were more deflected toward the north pole of the magnet. So, considering these points, As the discovery of the electron was done by Crook, he gave all these characteristics to the cathode rays, and considering these points that cathode rays are there, as there are cathode rays, so Thomson also thought of this. If there are negatively charged particles, there must be there some positively charged particles. So J.J. Thomson, he did the discovery of protons. He again took the same discharge tube. But now what he has done differently, he attached the positive terminal of the battery, okay, and to the positive terminal of the battery, he made anode in the first part, and the second part was perforated cathode. The negative plate, the negative plate was perforated. And what different thing he did from the Crookes tube? He added hydrogen gas in place of helium neon or argon. So what he did, he just bombarded, he just bombarded the anode with the positive terminal, and the protons were projecting out. As what happened in this case? Hydrogen gas was ionized and the protons were ejected, and they were now the part of anode rays which were moving towards the cathode. So in this way, anodes were discovered. Later on, Chadwick, scientist, he did the discovery of neutrons. So next, what we are going to study, that is called as Mulliken oil drop method. What he did, what Mulliken did, he gave us charge to mass ratio of electron. Okay. So at that time, mass of electron was not known. Charge to mass ratio was not known. So how he done the experiment? How he did the experiment? What he did? He took a steel container. I will show you that. See this. See this. How Mulliken did this oil drop experiment? He took one steel container which had two metal plates. One plate was connected with the positive terminal of the battery, and the other was connected to the negative terminal of the battery. So through one port, he used to spray oil droplets with the help of atomizer. Atomizer is an equipment which can spray a mist of oil, which can spray a mist of oil droplets. It's like किसी चीज का एकदम से फ्लो करके जाना, धुंध जैसे बन जाती है वो. उसने ऑयल ड्रॉपलेट्स को एटमाइजर से पंप किया और ऑयल ड्रॉपलेट्स को इसके अंदर स्प्रे इन कर दिया स्टील कंटेनर के अंदर। तो जब उसने स्टील कंटेनर के अंदर इसको स्प्रे इन किया तो उस पॉजिटिवली चार्ज प्लेट के ऊपर एक होल था। With the help of gravity, these oil droplets were moving just inside the plates area which is present in between the two plates, that is the positive terminal as well as the negative terminal. Now he added X-rays. These X-rays were ionizing the gas which is already present in the steel container. These gas, when it was ionized, it released electrons, and the electrons charged the oil droplet with a negative charge. So this was visualized with the help of viewing microscope, and Millikan concluded that charge to mass ratio. Basically, what happens when the battery is connected, there is voltage, and when the voltage is there, the gas was ionized. As the gas is ionized, the electrons are ejected from the gas molecules because there is air molecule. So there is sufficient of full of gas, full of air molecule, full of nitrogen, full of oxygen, full of hydrogen gas already present there. So these gas molecules were ionized and the electrons were ejected out of the gas because X-rays were falling on these gas molecules. So electrons which were ejected out by the ionization of the gas were now surrounding the oil droplets. They were surrounding the oil droplets. So as these oil droplets, they were falling towards the negative terminal of the battery, negative terminal of the metal plates. So by just visualizing the mass of oil droplet and the charge on the oil droplet, he could predict the charge to mass ratio. So what is basically the charge on the electron? The charge on the electron is 1.6 into 10 raised to power minus 19 coulombs. And mass of the electron is 9.1 into 10 raised to power minus 27 base. If it is in kilograms, it will be minus 31. So he calculated charge to mass ratio, which came out to be, now divide both of these two, this will came out to be 1.74 into 10 raised to power minus 11 minus 11. So he was the first scientist who told us charge to mass ratio of the electron. So in the next lecture, we will be discussing Rutherford model of the atom. Thank you.